So given an integer array numbers and an integer key, so return true if numbers has a continuous subarray of sets at least 2 and whose elements sum up to a multiple of k. So an integer x is a multiple of k if there exists an integer n such that x equals n times k. So notice that 0 is always a multiple of k. So next, let's look at several examples. So in these 3 examples, the numbers array are essentially the same, besides some order orders. So in the first example, it returned true because there are subarrays has sum, which being a multiple of k. For example, 2 plus 4 is 6 is a multiple of 6. Also, actually, we can look at 2, 4, 6. They add together 12 is also a multiple of 6. In example 2, so the whole array adds up to 42, which is a multiple of k. In example 3, there is no subarray which sums to a multiple of the prime number k, that is 13. So next, let's look at the constraint. So here we want to talk a little bit about the first one and the last one. The first one is the length of the numbers, which can be up to 10 to the power 5th, which tells that if we want to solve the problem using a brute force fashion, it may not pass the test. So lastly, so we have a constraint on k, which is greater or equal than 1. That is, k is not allowed to be 0 in this problem. Okay, so with this problem explained and the examples demonstrated, let's look at the main idea for solving this problem. So the main idea for this problem is to use abstract data structures to help solve the problem. So here what we are going to use is dict or map. So here the question related to this solution is that how do we effectively record the partial sums, or how do we effectively get the subarray sums? So how to effectively check subarray sums. So here is the idea. So suppose we have 2 arrays, both starting from 0, but one ending at index I and one ending at index j. For example, this one, so ending at index j with a sum si, and another one ending at index j with a sum sj. Then the subarray sum from index I plus 1 up to index j is nothing but sj minus si. So because I and j are actually arbitrary, so we can recover all subarray sums in this fashion. So in this problem, in order to check that, we do not need to store the sums. Actually, we just need to store the remainders modulo k. For example, if sj minus si modulo k equals 0, which says that the subarray starting from index I plus 1 up to index j has a partial sum which is a multiple of k. Or put another way, it says that sj and si are equal modulo k. In other words, they have the same remainder modulo k. So this is the main idea for this problem. Now let's look at the code. So let's do it in a stepwise way. Step 1, let's initialize the map data structure. So initialize a dictionary. So here we can call it M. So it's a dict. So we can do it like this. So here we want to not simply initialize an empty directory. So the reason is that we want to treat the case if there are some subarray which has a sum being a multiple k but starting from index 0. So in this case, we are going to add this 0, -1 pair. So this -1 is dummy, it's before 0, right? So here we want to emphasize that we are recording the remainder index pairs. So this is step 1. Step 2, we want to do a linear scan of numbers. During the scan, we are going to update a remainder variable. So let's first initialize a remainder variable. Let's call it remainder. Then we iterate for I and y in enumerate numbers. So then the rule for updating the remainder is like this. So remainder plus the current number, then modulo k. So next we are going to check whether the remainder has appeared, has been in the dictionary. So if it were the case, we are going to find a result. So if remainder already appears in M, this means that let's call this index M remainder. So this means from 0 to here, this is one array, and from 0 to the current index I. So these two arrays have the same remainder. Or put it another way, it means that the subarray starting from M remainder plus 1 and ending at I has sum and being a multiple of k. Okay, if this was the case, here we want to come back to another important constraint. It means that the continuous subarray should be at least length 2. So in this case, we just need a check. So here we check if I minus M remainder is greater than 1. If this was the case, we get a result, so we return true. So otherwise, we should update the remainder, because if the remainder does not appear before, we are going to see now it appears. So its remainder equals I. So if after the linear scan we do not return anything, we are going to return false. So this is the solution to this problem. So obviously, because of step 2, this solution is a linear solution. So let's check for some cases. So this is example 1. Let's also check example 3. So let's change this 6 to 13. So then it returns as expected. Now let's check all the cases to submit. Oh yeah, so that's it. Thank you very much.